Welcome back to the video lecture series for Introduction to ER Programming using Scala. In the last several videos we talked about sorting. We looked at the bubble sort, the selection sort, the insertion sort. We looked at how we could kind of visualize those sorts, and now we're going to switch over and look at searching. Okay? Now a lot of times the reason we do sorts is to make searches more efficient. But we're going to start our discussion of searches with a basic search that really doesn't benefit from any type of sorting, and for that reason doesn't need elements to be sorted. And this is a sequential search. Now the sequential search is actually implemented in the API in all of the collections. And if you go and you look in the API, if we go down into our collections and look at, for example, the sequence, which all of the methods that we actually, let's go ahead and just look at our list. The methods that we're talking about here will also work just as well on an array. And there are, we talked about, for example, the find method, which returns an option of A. You get to pass it a function, a predicate, and it will give you back the first element that satisfies that predicate. A more general form of the sequential search comes in the index of methods. So index of an element. And we can look at how we would use this inside of code, and then we can write our own. So if we write a new file, search.scala, I'm going to make a whole bunch of numbers here. Actually, I'll go with an array. And at least to start with, I'll type in some random numbers, and I can use index of to find the index of a particular number inside of there. Nums.index of, let's say I want to find the first occurrence of 4. Okay. Now what this is going to do, the way a sequential search works, is it starts at the beginning and it checks the first item and says, is this what I'm looking for? Is this what I'm looking for? Is this what I'm looking for? Boom, 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 until it finds something that matches, or until it gets to the end. In this case, the index of 4, of the first 4, is 4. 0, 1, 2, 3, 4. There it is. Just to check the sanity on this, we can check for a 7 as well. Okay, and that's at index 5. What happens if I look for the index of the number 2? That gives us back a -1 because 2 does not occur in this array. And it's standard for these search algorithms that give you an index to give you -1 if they cannot find the thing that they are looking for. There's also, so you'll notice index of, there's another version that takes an index to start from. So if I wanted to find the next 4, I could start from the index of the last 4. There are also methods for last index of, so that you can start searching from the end. There, you might notice an index where. This goes back to looking at for a predicate, but whereas find gives you back the thing that was found, index where gives you the index where the first element was that satisfied that predicate. Now instead of using the versions that are in the API, I'd like for you to actually understand how to write a method like this. So we're going to write a sequential search, and it's going to take an array. We'll go with an array of ints, and the int that we're looking for, and it's going to give us back an integer because this is our version of index of. And how does this work? Well, it's supposed to run through and keep going until it finds the thing that we're looking for in the array and then return that index. Now because it's supposed to break out early, this is one of those situations where a while loop is probably preferential to a for loop. You could use a for loop here, but it's really not ideal. So instead, I'm going to create an index variable, I, which will start at 0. And while, well, there are two possible reasons why I would break out. One is I is greater than or equal to a dot length. So I want to keep going while, whoops, sorry, let's turn that around, while I is less than a dot length, and a sub I is not equal to looking for. What do I do? Well, in this case, it's really simple. I move on to the next one. When we're done, there's two possibilities here. So I could just return I, but it turns out the way this code is written, if I run past the end, so if the thing isn't found, then this would return the a dot length, and I don't want that. So I'm going to say if I is less than a dot length, then I return I, else I return -1. Okay, so let's see how our version of the sequential search works. I'm going to pass it nums, and I'm going to search for the same numbers that I did before. So a 4, a 7, and a 2. And indeed, our function works. We got 4, 5, 1 before, or 4, 5, -1 before, and we get 4, 5, -1 again. So this is what a sequential search looks like. It's not a very difficult piece of code. It's fairly straightforward. The advantage of a sequential search is it works on any array or list, and you give it whatever data you want, and it will find or not find what you're looking for in a very reliable way. The downside of this is that it's not very efficient. Now, it's fine for an array this size, but what if I had an array with, say, 100 million elements in it? Well, the sequential search has to go through every single item until it either finds what it's looking for and it runs out to the end. And so, especially in the case where the thing that you're looking for might not be there, you can go through the entire array as part of this search. The sequential search is order in. Okay. It happens in linear time. As the number of items grows, the number of comparisons that we expect we're going to have to do grows equivalently. Okay. So this, while it's flexible, it's easy to write, it turns out that if you're going to do this a lot on larger sets of data, this is not the way you want to be doing it. And that motivates our next lecture, where we're going to talk about the